Hello, everyone. Exciting. It's the last day of the conference. So many good talks, excellent keynotes, and I'm happy to introduce you to elevating experiences with service and events in Django 5.0. So let's get started. So who am I? I'm Melhin. I've been a software engineer for a decade, mostly fumbling at building softwares. I work at Kimondis. I'm an engineer, and I lead a team of engineers. Kimondis is a marketplace for chemicals. I have a lot of projects on GitHub that are incomplete. So, and if you want to see those projects, this is my handle. Let me start with some caveats. I'm a first-time speaker, so I'm bound to make mistakes. I'll show you a lot of code. That is how I would like to explain what is going on. The last time I got recorded on camera was a slow-moving car crash. I hope it doesn't happen this time. And I'm also easily distracted, so I hope I don't go on a tangent. So, Django. I'm going to do this a little more, but how many of you use Django? All right. How many of you use Async Django? And how many of you have used other frameworks like FastAPI or Lightstar or Starlet? All right. So let's cover our bases. I'll quickly go into some kind of definitions. And the first thing that I want to talk about is polling. Simple, old school. Client repeatedly asks an interval to the server. It's like a little kid asking, are we there yet? Are we there yet? Are we there yet? And there are two things, the short polling and long polling that we have. How many of you still use polling? OK. The next one is WebSockets. It's bidirectional between client and server. The message flows in both the directions. It's done over TCP. It's not part of the normal HTTP flow. And the next one is server-sent events. It's a unidirectional over a single HTTP connection. And the client establishes the connection. The server holds the connection and sends back data. Has anyone used server-sent events? All right. So quick look at how the stream format looks like, right? So by definition, an event stream is a simple stream of text messages that is UTF-8 encoded. And the messages are separated by a pair of new lines. So that is basically /n/n. There's also something in the format that has a representation where you have a colon, and the colon is a part for the comment. Let's take a look at it, right? So this is how a normal event looks like. And you could see that whenever there's a /n/n, the message is sent back from the server to the client. And the colon is, as you see over here, it's just a data is set as a comment. There is another type of event, and that event is known as a named event. And it looks something like this. So here, you could see that the event has a name, and the data is just another UTF-8 text. This is really useful because you could have multiple events on the same connection. Let's jump right in, right? I'm going to go show you some code as a simple one. So this is a simple counter streaming example. All it does is sleeps for a second, counts, sends the data. Let's take it apart. So you're able to see, yeah, OK, that's good. So you see the highlighted part? The highlighted part is an async generator. And what it does, it's the main core, right? So it basically sleeps for a second, it increments the count, and yields the count. And this is how the event data is basically formed. So event data has a name new, and also has the count as the data. Now let's look at another component. And this is the streaming HTTP response. Streaming HTTP response has been around in Django for a while, right? And streaming HTTP response in the sync world holds the connection, holds the worker, sends back data. And you usually use this for sending large CSVs, Excel files, and things like that. In the async, that's the sync. So basically in the WSGI, in the async side of things, it uses the event loop. So you can basically have multiple of these without holding up workers. Disconnection. So this is partly why my talk was saying Django 5.0, because disconnection has been handled properly from 5.0. I think from 4.2, if I'm not mistaken, the streaming thing had the async stuff, but the disconnection was a bit tricky. I also had an initial version of the code which said to do fix when 5.0 gets released. And in the discussion, disconnection is basically the place to have cleanup code. So normally, when you have client-dependent disconnection, there's always a chance for failure, right? Because when you close a tab or close a browser, for instance, you're not exactly notified that this is closed. So with this one, you can actually expect this error and then do the cleanup accordingly. How do you develop this on local? So this is a little interesting. In my experiments with async and streaming HTTP, I found that it's easier to do using UVCon rather than the run server, because the run server was getting stuck. It basically took in all the streaming responses and didn't respond. You could actually make the run server work if you have installed Daphne. So, because by default, Daphne had that. So that just works out of the box. A few things to note over here. So you could see a reload and timeout graceful shutdown. Now, this is important when you're doing it in your local, because otherwise your experience of developing local gets worse, especially the timeout graceful shutdown. Because as you realize that the HTTP connections are held, they are not released. So the server doesn't reload. So this is just a small hack to do that. I'm not good at doing live demos. So I'm going to just show some screenshots of how it looks like. So this is the server logs, right? The same streaming HTTP sleep counter. And this is the client. And as you can see, right, you don't need to do anything fancy over here. It's just a curl command on top, if you can see that, yeah. And you see the server events and also the logs on the client. Why are we embarking on this journey? I'm going to sound a little product over here, but our primary focus revolves around delivering substantial value. We select standard frameworks that have a good ecosystem, that have also a good community behind it, is pretty stable, not just in production, but also the framework itself, and also has a decent upgrade history. And Django has been around for close to 20 years or something like that, has a solid ecosystem, has third-party libraries, is battle-tested, and is also robust. But there's another thing also. I got an inspiration from one of the keynotes. It's about exploration. So when you don't have, when you've never tried async Django, this is actually a good opportunity to give it a try, because you also get something out of it. I want to stress another important point. If you would like to also understand some async concepts in detail, look at Django's code. Django's evolution of how do you implement a predominantly sync framework to an async framework is a very interesting choice. And I also heard in another talk that it's actually more progressive than saying, hey, let's stop shop, let's switch everything to async and then build the new cool features, but rather giving more and more value as we move to new things. Now, real-time interactions, as everyone know, right, it's basically enriches the modern web application experience. It just depends on what app you're building or what applications in general need this kind of experience. Some of the examples in general where real-time functionality is useful is, of course, messaging apps, collaborative tools, live streaming platforms, online gaming, and of course, real-time dashboards. But a lot of our applications are not exactly falling into these categories, but still can do with some kind of real-time. And that's where we can use notifications, right? Very useful, common pattern to understand. You get new updates for refresh. And it also makes it a little more easier to offload heavy workloads on like a salary task or something like that and keep getting updates of what is happening over there. Now, how would you do that? In a typical scenario, let's say you have your sync app that is running on production, has been running on production for years. And what you do is you basically keep the synchronous app running as it is, because you've also heard in other talk about the DRF not being async friendly, and there are so many things in the components that are still not completely async friendly. That is not on the framework side, but predominantly on the third-party modules that we use. Then you add listeners to the interactions. So wherever you need to notify the users, you basically add some kind of listener. You publish this to a common channel. I'll come to what a common channel is. And then you run your application asynchronously in a different app, which basically listens to this common channel. There is a really interesting talk about this concept by Carlton. I will point the links towards the end of my talk. And how does this look like? I'll just try to represent this pictorially, however I can. So this is your normal application, right? Your sync app has been running for years. You add now the async application. So you can also make, if you're running this separately, you can also make of the existing authentication. You don't have to add anything else. Then you have the server streamed event connection. So when the client connects, it goes to the async app, and the async app then listens on a stream, right? So this loop is complete. Now, when you have something on your sync, your async app listens and sends it back. So predominantly, this is an exploration. So I believe this is something that we can try out without disrupting our synchronous app. I'm going to give another talk in DjangoCon about streaming, so I'm basically evangelizing streaming to see if we can use it. And in that talk, I'm going to explain this a little more in detail. But over here, let's take another example. Anze stored my thunder. I wanted to talk a little bit about Fediverse, but he has already mentioned it. But how many of you have heard of Fediverse? How many of you are on Mastodon? Yeah. So Mastodon is a cool place to hang out. A lot of interesting people in Python and the Django community. So let's take an example of using something like that, right? So let's consume a Mastodon stream, update the process, let's consume the Mastodon stream updates, let's process them, and then redistribute them in real time. Let's break this down again in steps. Stream consumption, right? Collect Mastodon stream updates like how we used to collect tweets in the olden days via sync app. Let's parse the update, store it in a different structure, and distribute them. So this is how it would look like. Again, I'm just trying to do it in a diagram, predominantly same way. And here we are looking at Redis as the common channel. Now, why do we select Redis as a common channel, right? Redis is predominantly always deployed along with the other applications that we have, so it is readily available. You don't have to use another infrastructure. Redis also has a lot of data structures that we can actually support. And one of those Redis data structure that I want to talk about is Redis streams. Very interesting, released in 5.0, can be used for different kind of topics like event sourcing, log collection, and also notifications. And how would that look like? You can listen to multiple streams, not just one. So you can listen to a post stream, and then you can listen to a user stream. And then you can just have one listener. So it doesn't have to be just 2 streams. You can listen to multiple streams, and then the listener can decide which combination it should listen to. So in this case, it's just a post and a user stream. Let's look at how the code looks like. So this is listening streams together. It's predominantly this simple. The last ID returned is something that we have to store, but after that, on any stream, any message comes in, this method just gives it back. How does the view look like? You're able to see it? Yeah, okay. Let's take it apart again. So, as I said, user connection stream, right? So you're basically sending the status that someone is online. And then the next part is where you are listening to the multiple streams, right? So it's just a while true loop, nothing fancy. And based on which stream, you can actually form different events. So in this case, I've given an event status and an event new notification just to differentiate between them. Based on that, your client can react. And you can also send heartbeat messages. And this is very important because this is some of the load balancers disconnect the connection when there's idle. So it's always good to send a heartbeat. You can also build different functionalities on top of it, like putting it in like on online user counter or something like that, yeah? And on disconnection, you just send an event of disconnection. And this is also a place to clean up, I don't know, Redis connections or things like that. At the front end, even though I wanted to do it completely HTMX style, let me just explain in detail why I didn't do that. Here, you could still see there is a small HTMX process over there. But in general, it's very simple. It's just an event source on the JavaScript side where you connect to a stream. It automatically also reconnects, right? And with credentials, you could also just pass on your cookies. So that's great. And then you can add listeners. So in this case, there's a new notification. You just react to a new notification. Please don't judge my JavaScript code. It's not that good. But and then finally, what we do is you take something from the event, and then you call another endpoint. If your connections maintain state. So in the case of notifications, yes, your connections maintain state in the sense you would always maintain whether user has read a particular notification or not. In that case, you can just use HTMX as it is. This is that simple. Now, why not just use WebSockets? Now, a lot of times you don't need bidirectional communication. Most of the times you need some kind of notifications. And you also need to change something in your infra. You have to, if you're set up Nginx for WebSockets, you know that there's always some tweaking going on. Your load balancers might not support the protocol. Compression is not supported out of the box. There's a very interesting talk about this whole thing about SSE, WebSockets, and long polling by Martin. It's in YouTube. It's really interesting. It also talks about HTTP2 and multiplexing and all those kind of things. Now, is it really rosy? Unfortunately not. Also, it depends. But there are some caveats. So one of the caveats is your settings file have been around for a long time. So there's so much of settings depth in it, and you'll have to basically clear them up. Middlewares. There are Django middlewares and third-party middlewares, and some of them are not async yet. So you'll have to look at how you want to do that. The install apps, your own apps at some moment are not really, so as I said before, right, we're running both in parallel. So you're not changing a lot of those core things. And the final one is a connection limitation. So SSE browsers implement this limitations of having 6 connections or something like that. You will have to get over this somehow. If your users are bound to open like 10 tabs of your application, but if it's just a mobile application or something like that, it's not usually an issue. But you could get over something like using the core native JavaScript functionalities like broadcast. A little bit about middlewares. If you want to know how this is implemented, please look at Django again, because Django has actually shown us how you can actually convert a sync middleware to another one. It's fairly straightforward and really interesting, and it mainly uses thread pool executors. I think there was also a talk about Async.io where this was mentioned, and I found it really interesting how thread pool executor in general is used. So if you take away anything from the talk, server-sent events, Redis streams, and of course, Fediverse. I did some small performance stats. Take it with a grain of salt. I ran a render instance, a free one of 512 MB, very little CPU, and the timer one gave me like 500 connections, and the stream connection with the whole Redis gave me like 150 to 200. Still, as just a reference, again, we are exploring. We have not explored, we have not deployed this on production and saying it, but yeah. That's it.
Thank you very much. Okay, we have a few questions. Actually, a lot. So first one, how do you deal, no, one moment. Okay. What are the pros and cons of servers, events versus WebSockets? The talk that I mentioned before, one of the things with WebSockets is always about tweaking your infra. But still, it could be useful in different cases, like bidirectional communication. But otherwise, server-sent is just predominantly based on HTTP. And you can also use HTTP2 functionality, like multiplexing and things like that. I don't know if I answered the question. Yeah. In long polling, the server holds the connection, but eventually needs to close it, and client needs to poll again.
Yeah.
Is this now required in server streams?
No, no. You can do that. You can just hold the connection.
Cool. How do you deal with the license change of Redis?
Interesting question. So I was also recently, when I was proposing this talk, at that time I think the license change didn't happen, but on a later stage it happened. And I think I tried out Dragonfly. You could also look at that, because at the end of the day, there are so many different Redis alternatives that are coming in, but they all implement the Redis protocol. So you don't even have to change your library. You can just directly use Redis Pi and connect.
What's the difference between SSE and WebSockets in the point of view of the load balancer?
I think in the load balancer, if I remember from AWS, the ELBs were not supporting it because it didn't allow it, but the ALBs do it. And there are some load balancers with some tweaking, because it's not the normal HTTP flow. It's a little different.
Right. What's the easiest auth method for SSE in your opinion? JWT, cookie, should we use the same as in the sync app?
Sorry, is it the authentication?
3 questions in one. What's the easiest auth method?
Yeah, okay. So what I tried, I can tell you what I tried. What I tried is to use the same Django's session cookies. Because the event source, if you've seen that, wait, let me just quickly show you. Yeah, here. You see the with credentials? It just passes the cookies. So you don't even have to implement any other changes on your authentication side.
All right.
Any other question from the room? Okay, I have another one on Slido. One moment. What about synchronous DB access? Is it a limitation?
No, I mean, the ORM, the recent versions of the ORM have all async versions. So you get a get, a filter, and stuff like that. So you could just use it as it is.
All right. Someone? We still have 5 minutes. All right. Thank you.
Thank you.